Alright, YouTube. After further analysis, evaluation, and extensive editing, episode 20C, take 2, new intro. Welcome back, YouTube. This is the final installment in this saga of everything that's happened over the past couple of weeks on this bus. In this particular episode, we're going to go through some things that I learned about Victron Communications, a long laundry list of lessons learned and other activities that proved to be quite eye-opening, and some things that I want to share with you that maybe you know, maybe you don't know, but I'm going to run through it anyway. And try to enlighten you on some things that I learned so you don't make the same mistakes. With that said, let's get started. Well, welcome back, everyone. It is Wednesday. It's 2 days later, as you're well aware, and it's time for me to give you a very serious rundown on everything that I found, some serious lessons learned, and what actually happened on the last episode. One of the biggest things was my battery died as I was about to switch over. I'm going to run through some things that I found. Guys, one of the things that I have to tell you, which I thought I had covered, was attention to detail is critical. And one of the biggest challenges that I was running into is that I couldn't get my MPPT controller to show up on my Servo GX. Couldn't get any ability to go in and program it or anything like that. Wasn't sure what was going on. Obviously, the pin codes, I should have known better and got that beforehand, but I didn't. And some other things that I found. So one of the biggest challenges that I ran into with what you were seeing previously is that yours truly learned a very serious lesson about Victron Energy communication protocols. I wasn't paying attention, and I even made reference to it and put a comment so you could pull it out. But so my MPPT charge controller works exclusively off of either VE Direct or VE CAN. Well, the way that I had this set up was I had the VE CAN output of my MPPT going into the VE bus input of the inverter, daisy chained over to the other one, and then the other inverter coming up to the Servo GX. One of the other things that I realized in all of my work in connecting all of those connectors is that there are three possibilities for connections on the Servo GX with regard to Ethernet type cables. One is BMS CAN, which is, in my instance, all the way on the right, and there's 2 ports for that. In the center is VE CAN, and then on the far left side of the Servo GX, the way that it works in my installation, was VE bus. So VE CAN requires terminations on both ends. VE bus does not. It's, I don't know, for lack of a better way of putting it, it's like standard Ethernet cables. So I had everything tied together in a single string running off of VE CAN going into the Servo GX, and both ends terminated. Well, that didn't work. When I brought my inverters up, because my camera died, and I went ahead and kept working because I wanted to get everything up. When I got my inverters up, they wouldn't show up either. And I started troubleshooting and started looking, and I started realizing, and I realized that I had a mix match of all these communication cables going across all the different components, and that's why they weren't showing up. So bottom line, inverters, VE bus, nothing else. No terminations required. daisy chain them over, plug them into the VE bus inputs of the servo, turn them on, they're there. The MPPT going into the Servo GX, VE CAN requires, I'm assuming it's a different protocol connection, whatever the case may be, but requires a termination on both ends and goes into the VE CAN ports of the Servo GX. Unless you have a Victron Energy BMS or BMSs that have a VE CAN capability for communications, you don't put anything in the VE CAN bus. And so that was the issue that I was fighting. That was the problem. That's why everything wasn't coming up. I worked on it on Monday for a while, trying to figure it out. Did some homework, did some research, and couldn't figure out anything. Went back after it again on Tuesday, started really digging into the connections that I had, and that's when I realized that I had everything crossed over, screwed up, and all that kind of stuff. So I got that all fixed. I got everything powered up. Everything is showing up. One of the other issues that I ran into, in a very serious lesson learned. So when I was pulling all of this together, I got the VE Smart dongle, which I thought would give me Ethernet access, or not Ethernet, Bluetooth access to the inverters so that I could configure them. You can configure them with the VE Smart dongle, but it is very limited, and it is not an installation level configuration that you can do. You can do power assist, you can do a very few limited things, but the Smart dongle does not give you a lot of capability. I thought that you would be able to do configurations through the Servo GX on the inverters once you got them connected. Not true. So what I had to do is I had to go get me an MK3 USB to VE bus converter. It will be here tomorrow, and when I get that, then I will be able to configure my inverters. So right now my inverters, they have power, they power up, but they're not configured because I can't configure them until I get that thing and I connect it to either my phone or my computer. I went ahead and downloaded all the necessary apps and software and things like that that I need to make that happen. I will give you a rundown on how that works. One of the other things that I learned, and it was out of desperation for no other reason, is that everything that I've ever seen, everything that I've ever watched, everything that I've ever tried to learn about Victron equipment and stuff is that everybody always says you got to use Victron cables, you got to use Victron cables. Guys, I'm telling you, I went into a stash of Ethernet cables that I had that I got a long time ago, and I found a Cat 5 cable that was long enough to stretch across the length of my equipment cabinet that allowed me to plug in VE CAN on my MPPT to VE CAN on my Servo GX, and I had everything on, and as soon as I plugged it in, everything came up. I'm not so sure why everybody says you got to have Victron cables. Maybe it's better, I don't know, but a standard $5 cable replaced a Victron cable that cost probably twice, if not more than that. So one of the things that I am going to do as a test, I've got Victron cables that run my VE bus connections. I don't like them because they're too short. I have longer Cat 5 cables. I am going to try to use the longer cables that I have for the VE bus connections to see if they work as well. If there's any issues, I'll let you know. The daisy chain cable that goes from one inverter to the other, I'll leave Victron because it's short enough and it works well, and it would be a pain to get it out. But all the other ones I'm going to try to change and see how that works. When I get that MK3, I'm also going to run a feed cable that goes through a pass-through that will allow me to actually work and configure on the relay on the inverters without coming into the cabinet and going all the way back to the back. I don't like being inside the equipment cabinet now that I've got power applied to everything. It just makes me nervous. So action is happening, and there's a lot of power in here. So I wanted to give you a rundown on that. So with that said, let me take this little camera thing and let me show you what it looks like with everything powered on and everything actually registering with the servo. So right now we are on the 24 volt side, the Servo GX. I changed it back over into classic UI so I could more effectively show you the difference. But as you can see, my inverter is on. It shows that it's inverting. They're showing that there is a total of 4 or 5 watts of AC load. I'm assuming that's the internal power consumption of the inverter because every electrical breaker in my panel is off. There is no external loads on that inverter whatsoever. There cannot be. So that's got to be AC loads from inside the inverter and not external. Going to my batteries, they're showing at 100%, 40 watts of power coming out. Currently sitting at 26.5 volts and a total of 1.5 amps of current coming out of them. My DC power consumption that you can see coming out is a total of 5 watts right now. The yellow box that you see right there is my MPPT, showing 0 watts of solar input because I don't have any solar panels connected up. So there is everything that is connected and registering right now. If I was to hook up shore power, that red box in the top left would actually show my shore power input. If I had everything terminated and connected and had everything running on AC, it would show what the total wattage output of that is. If I had the bus running, it would show how much current is coming from the DC to DC charger into the batteries while the bus is running. So works very well. One of the other things that I do want to show you, there's several different pages that you can scroll through with regard to how you have this set up and what you have connected. But what I want to do is go to menu. One of the things that I did last night as well is I actually went ahead and connected up all of the correct what am I trying to say? All of the correct battery temperatures, because I got those in. So as you can see right now, not what I wanted. I have my at the very top, I have my inverter right there, 24 volt DC L1. That's the one that's on. I can't turn the other one on because I don't have the ability to configure it for split phase. Then I've got my 24 volt DC MPPT, not doing anything because nothing's connected. Then I've got my battery temperature for my 1, 2, 3, 4 batteries sitting at 68. Battery temperature for 3, 4, 5, 6, that should be 6. Can't get too close to it. 3, 4, 5, 6 is 70. Battery temperature for 5, 6, 7, 8 is 66. And my compartment temperature is 73, which is this battery temperature right here. So they're all working, they're all registering, and I've got alarms set up for every single one of them if any one of them gets too high. For the battery temperature, all it does is sets off an alarm and lets me know. For the compartment temp, it actually turns on the fans. Now you can see I've got my smart shunt registering and reading what I've got right there. Everything is showing 100% on my batteries, and that's based on the current battery voltage. And so after I got all of that squared away, got all my lessons learned, got all my COM ports connected and corrected and all of those kind of things, everything came up as it was supposed to. Just lesson learned, ignorance of the equipment, ignorance of the communication protocols. Took me a bit to figure it out, got it all figured out, and now it's all working. So everything on the 24 volt side is up and running and has power. My second inverter is off because it's not configured for a split phase, and if I do, it gives me a crap ton of errors that I just don't want to deal with. And it's because it's not configured. The other thing that I want to show you is I now have all of the fuses into my Lynx distributor, and you can see that I have the single green LED right there. So if any one of those fuses blows, that turns red, and the associated LED with that fuse also lights red and lets me know that I've got a blown fuse. That is not standard. That is a makeshift and hack for the Lynx distributor that I found, and kind of did my own thing with it, but that's what this converter is for. It takes 24 volts in, puts 5 volts out. It connects through this little cable right here into there. which simulates the input from the other BMS components that would provide that 5-volt power to make that work. I don't have those, so created my own little system. And it works. I was happy with that. I watched a lot of videos on it to make sure I fully understood what I was doing, because I don't want to blow something up, but got it all working. I have checked my servo. It does work on internet. I use a hotspot that I have for that. I can connect it to the internet. I have downloaded the VRM app onto my phone. I will put it on my computer, because I think to configure these inverters the first time, I have to actually do it from a computer. So figure that out, and that'll be part of the activities that will kick off my next video, and that'll be the smoke test part 2, because I plan on doing some branch circuit termination so I can actually trip some breakers on these panels and see what happens. So that's 24 volt DC side. Got everything sorted, got everything squared away, everything's working. The one thing that I have to deal with, if you notice right here, so inverters on, it says green, inverters off, it says red. Realistically, there should not be any power for that red LED to come on. I don't know how that works. I'm going to check that out. However, I'm not going to do that until I get these things configured and make sure that it's not a configuration issue. But inverter L1, it should be green, and it is green, so we'll hopefully that'll be taken care of. But I'm not sure why the red one is on L2. I'm thinking that I may have some wires crossed, and that should be green right now. But without the inverter on, there shouldn't be any power to the relay. I'm going to see if I can figure that out. Maybe there is. Maybe that's why it is that way. But I'll check that out and see what I can do to get that sorted out. Going into some of my other equipment, you can see that this is all working. My fresh is at 0. Galley is at 0. I got my lights on. I got my dome lights on. All of this is all running off of house batteries. I put some light on the subject. Closet lights are on. Everything is on, and I'm running everything. I'm trying to run the batteries down. I want to get them down to somewhere in the neighborhood of about 50% or below, and then I'm going to work on getting them charged back up. And where I'm going to start cycling them like that. I am nowhere near that based on my current time on task. Let's see. Go back to this. This one doesn't tell me. I should have one that tells me time remaining, but I think that's on the new UI, and I switched back to classic so I can show you the difference. So this is the classic UI. Now that I've covered everything on 24 volts, let's move over to well, actually, there's one more thing I want to show you. So if we come down here, it's a mess because I haven't cleaned it up, but as you can see down here, I've got all my temperature probes in, got them all wired up. They're all coming up, and they're all going to the Servo GX up top. I'm going to clean all this up and make sure that it's all nice and neat, cut off all the tie straps, but I did that late and just wanted to get her done. So now let's move over to the 12 volt side. Let's wrap this up, close this out so I can get this video out. So coming over here, so this is the new UI. This is what I've got showing up right now. You can see my inverter's on. It's showing inverting again, 4 watts on AC loads, which has to be internal loads from the inverter. My DC loads 56 watts, which is reflective of the fact that I have all the lights on. Basically I'm currently pulling 5.25 amps off of everything based on my Redodo, 5.1 off of my Smart Shunt, so somewhere in the neighborhood of just over 5 amps. And based on this, with the current rate that I'm discharging, it says I have 2 days worth of power before I'm going to kill everything. So my shore power is disconnected. My solar yield is 0 because I don't have anything. If I scroll through, my temperature sensor, which again is right here in the center of the room, is showing that my current temperature is at 77 degrees. If I go, I don't have any current alerts. Go to my device list. You can see I've got my MPPT at the top. I've got my compartment temp thermometer temperature gauge right there. I've got my 12 volt DC inverter right there, and I've got my smart shunt. DC to DC charger, for whatever reason, doesn't show up on anything because it's not directly connected. It's only Bluetooth, but it does show up in my Victron Connect app. One of the other things that I did that I want to reflect on and make sure you're aware of is that I had that smart dongle, and one of the things that I did was I permanently mounted the smart dongle in here, right there. It's kind of hard to see because of the way the light is. I've got my cable coming out of the top of it, got it routed nice and neat, comes over and connects up to the servo. No, it doesn't connect to the servo. Where does it go? Uh-oh. I'm losing my mind, guys. Oh, it goes up to the inverter. I'm sorry. It goes to the inverter because that allows the Bluetooth connection into the inverter for the connection setting changes that you can do with it. One of the things that I do plan on doing with that is actually setting up a feed through so that I can actually use that on both sides if I need it. I'll figure that out and get the cables ran and make that work, but I'm going to try to figure out a way that I can make that work for both sides. The other thing that I did, the smart dongle provides the ability to provide a temperature input as well for the batteries. So what I did, I had a BMV 712 that I used on the other side with the smart shunt, but because on this side I'm using the auxiliary input to monitor my battery voltage from the bus, I lost the ability to use that BMV 712 thermometer. So this gave me the ability to actually use that because it requires a 712 as well. So I've got that wired in, and it comes over here, and there it is right there. You can see that it's wired to the positive terminal of the battery, providing me battery temperature. I did it on the input side so that that always has power. Not really major, because again, when this thing is all turned off and everything's disconnected, my parasitic loads are less than a half an amp, or just barely at a half an amp, so I'm not worried about it. Once I get solar on it, it'll be a drop in the bucket and won't even matter. But so those are the things that I did. That's what I found. One of the other things that scared the crap out of me, when I finally got my inverter connected and the fuse in and all of that kind of stuff, because I was having so many other problems, when I turned the inverter on, it seemed like it was DOA. It wouldn't come on, anything like that. And I panicked and started trying to figure out why it wasn't coming on. I checked voltages, all of that kind of stuff, turned it off because it wasn't coming on. And last night, coming out here, one of the things that I did was I wanted to try it one more time before I started reaching out to support people to figure it out. I wasn't going to be able to return it because I bought it so long ago that it was going to be like lost investment, and I was going to have to get another one. But anyway, what I did was I turned it on, and then I went to the Victron Connect app and started bringing it up so I could see what was going on and see if I could figure something out by alerts or whatever that may be there. And lo and behold, the inverter came on. My problem on Monday night was I was just being impatient. I wasn't waiting long enough. There was nothing wrong with the inverter. It came on, it's inverting, it's working fine. I haven't checked power output at the outputs. I really don't have access to them, and I don't want to mess with that. As soon as I can get some AC outlets terminated, get some breakers on, I'll be able to check that and make sure all that works. This is all single phase. One of the smoke check part 3, which will probably be a little bit further down the road, but smoke check part 3 will be plugging my generator into this thing and see what happens. So that'll be smoke check part 3. But Monday was part 1. The next video will be part 2, where we actually start bringing up AC circuits and see what happens with the inverter. And then part 3 will be bringing shore power into this thing and see what happens on that as well. I want to check shore power input and charging. I want to check the ability to transfer shore power from my 24 volt side to my 12 volt side and make sure that I have my shore only circuits with my AC out 2 output on my inverter working as well. So with that, I think I've covered everything. I think I've cleared up everything. The lessons learned. Pay attention, guys. Make sure you know what you're connecting to. I sure thought I was. I sure thought I was paying attention. I pride myself in attention to detail, but I really screwed that up. So got it all sorted, got it all figured, got it all troubleshot, got it all working. Everything is up and running. As soon as I get that MK3, I'm going to start working on getting these things configured and set up so I can set up the inverting, the charging, all of those things that need to be set up correctly for the batteries that I have. And we'll be done except for testing shore power input. And that makes me happy because now I can get on to, once all that infrastructure is in place and tested, I can start moving on to doing what I'm really like dying to do, and that's start working on finish work and making this thing look pretty. So with that, that's a wrap. I'm going to close this out. I'm going to finish this up, get this video out, and immediately following this, we're going to go into the next video, and I'm actually going to start working on it as soon as I turn this camera off. So I appreciate you being here. Like, subscribe, tell me what you want to see, tell me what you don't want to see. If you want more detail on something, let me know. I'll do special videos or reels or shorts or whatever to cover that. Give me some comments, give me some feedback. I hope you enjoyed it, and we'll be back soon. Thank you.